පළවෙනි එක තමයි අපි මේ last month එකේ අපි මේ 15th of July ජූන් පටන් ගත්තේ. ඒක නිසා අපිට මේ 2 weeks තමා මේ අපේ ක්ලාස් එක කරන්න ඕනේ. ඒත් අර ගොඩක් ළමයි මේ ක්ලාස් 20 දාලා තිබ්බා. ඒක ඒ තුනට ඒක fair නැහැ. මට ක්ලාස් එක මේ කියන්නේ මම only two weeks අපි කරේ. ඒක නිසා මේ month එකේ මම එක්ස්ට්‍රා ක්ලාස් දෙකක් දාන්න අවශ්‍යතාවයක් තියෙනවා. ඒක නිසා පොඩ්ඩක් ඕගොල්ලෝ බලලා මට මේ ඩේට් එකක් ප්‍රොපෝස් කරන්න. මට ඕන වෙන්ස්ඩේ පුළුවන්. ඊළඟට ඔයගොල්ලෝ කියන ඒවත් එක්ක මට එතකොට එක්ස්ට්‍රා ක්ලාස් දෙකක් දාගන්න පුළුවන්. හරිද? මොකද මේ ලාස්ට් මන්ත් එකේ ගොඩක් කට්ටිය මට ෆී දාලා තිබ්බ වුණාට මේ ඒක මේ අපි ඇත්තටම 2 weeks නේ කරේ. ඒක නිසා ඒක එච්චර මේ ෆෙයා නැහැ ඒක මම ගන්න එක. මේ ඒක නිසා additional 2 weeks මේ month එකේ මම කරනවා. ඒක නිසා පොඩ්ඩක් ඩිස්කස් කරමු අපි ඒක අපේ group එකේ මේ මොන වගේ date එකක්ද මේ ගොඩක් කට්ටියට participate වෙන්න පුළුවන් කියලා. ගොඩක් කට්ටියට participate වෙන්න පුළුවන් date එකක් අපි fix කරගමු extra class දෙකකට. හරි? ඊළඟට මම මේ group එක ගැන කියන්න ඕනේ. මේ group එක තාම open group එකක් විදිහට මම තියාගෙන ඉන්නේ. මේ ඒකට reasons කීපයක් තියෙනවා. එකක් තමයි තාම පුතේ ඕගොල්ලෝ O level කරලා හරියට මේ අර transition period එකේ ඉන්න ඕගොල්ලෝ transition period එකේ ඉන්නවා කියලා කියන්නේ සමහර කට්ටියට decision එකක් තම හරියට හරි ගන්න බෑ. මම මොකද්ද කරන්න ඕනි stream එක කියලා. මම bio කරනවද maths කරනවද නෑ මම commerce කරනවද? ඇත්තටම මේකට පොඩි transition period එකක්. ඒ කියන්නේ decision එකක් ඔයගොල්ලන්ට හරියට ගන්න බැරි period එකක් ගොඩක් ළමයිට. සමහර ඉන්න හොඳ ගෝලයක් තියෙනවා. මම හැමෝම ගැනම නෙමෙයි මම කතා කරන්නේ. නමුත් සමහර ළමයිගේ decisions වෙනස් වෙන්න පුළුවන් time එක. හරිද? ඒක නිසා පළවෙනි දේ ඔයාලට මා fit වෙන්න ඕනි. ඒ නිසා ඔයාලට මේ chance එක මම දීලා තියෙනවා. ඔයාලට මා fit වෙනවද කියලා බලා ගන්න. ඊළඟට මේ transition period එකේදී එක එක මේ decision changes වෙන්න පුළුවන්. ඒක නිසා තාම group එක මම open තියාගන්න. මේ group එක open තියාගන්න මම සාමාන්‍යයෙන් තව මේ at least 2 or 3 months because we still we are doing unit number 1. unit number 1 කියලා කියන්නේ ඇත්තටම ගත්තොත් මේ physics වල මුළු මේ අපේ physics paper එකේම සාමාන්‍යයෙන් 1 mark point half mark වගේ කියන්නේ බොහොම මේ body evaluation එකක් කරන unit එක. ඒ නිසා මේ unit එක එකත් එක්කින් සමහර වෙලාවට boring වෙන්න පුළුවන් unit එකක්. ඊළඟට ලොකු evaluation එකක් නැති unit එකක්. ඒ කියන්නේ මේ අපි කිව්වොත් වෙන තේරුම් නැති unit එකක් වගේ. හරි. හැබැයි after this unit we have to do mechanics and waves. Those are the biggest unit in physics. ඒක නිසා මම ඕගොල්ලන්ට පොඩි chance එකක් දීලා තියෙනවා ඒ වෙනකන් ඔයාලට මගේ records මගේ ඒ කියන්නේ fee එක දුන්නත් නැතත් recordings බලන්න පුළුවන් එන්න පුළුවන් නොඑන්න පුළුවන් recordings ටික බලන්න පුළුවන්. ඒ නිසා කාවත් මම group එකෙන් අයින් කරන්නෙත් නැහැ. ඒ නිසා ඒ දිගටම මම continue කරගෙන ඉන්නේ. අවශ්‍ය කට්ටියට recording බලන්න. හරි. ඒක නිසා ඕගොල්ලන්ට මේ decision making මේ freedom එක මම දීලා තියෙනවා. හරි. ඒ නිසා තාමත් මම මේ විදිහටම continue කරගෙන යනවා. හැබැයි එතනින් පස්සේ after 2 months මේ අපි මේ LMS system එකකට තමයි යන්නේ මෙච්චර කල් ගියෙත් එහෙමයි. මේ එතකොට LMS system එකකින් තමයි ඊට පස්සේ අපි ක්ලාස් කරන්නේ පොතේ. හරි. මේක මේ පොඩි කාලයක් දක්වා continue වෙන session එකක්. ඒ session එකේදී ඕගොල්ලන්ට ඕගොල්ලන්ගේ decision making power එක මම දීලා තියෙනවා. හරි. ඒ නිසා ඕගොල්ලන්ට ඕන විදිහට මේ recordings බලන්න පුළුවන්. ඒ recordings මේ වලින් ඕගොල්ලන්ට මේක fit වෙනවද නැත්නම් එහෙම නැත්නම් ඕගොල්ලෝ වෙන subject එකක් කරනවද? ඒක ඒ decision ටික ඕගොල්ලන්ට ගන්න පුළුවන්. හරි. ඒක නිසා සාමාන්‍යයෙන් 3 months 4 months විතර මේක මම continue කරනවා මේ විදිහට. ඊට පස්සේ අපි අපේ LMS system එකට LMS system ආවට පස්සේ අපිට ගොඩක් වෙලාවට Zoom වලින් නෙමෙයි වෙන්නේ. LMS system එකට ඕගොල්ලන්ට login මේ username password තියෙනවා. username password දෙකත් එක්ක ඔයගොල්ලෝ ඒක තමයි log වෙන්න ඕනි. log වුණාට පස්සේ ඔයගොල්ලන්ට මේ අදාළ link එක පේනවා සහ එතනින් පස්සේ තමයි එතකොට ඔයගොල්ලෝ මේ class එක join වෙන්නේ. හරිද? එතනදී ඔයගොල්ලන්ට වෙනම profile එකක් අපි හදනවා. profile එකක් හදලා මේ ඒ profile එක through ඔයගොල්ලන්ට log වෙලා මේ class වල තිබ්බ recordings බලන්න පුළුවන්. download කරන්න බැරි වෙයි. බලන්න පුළුවන්. ඒක on time බලන්න පුළුවන්. ඒක LMS system එකක්. ඒක after 3 months වගේ තමයි ඒක apply වෙන්නේ. ඒ කියන්නේ තාම මේ ඔයගොල්ලන්ගේ තව මේ transition period එක නිසා. හරි. ඒ නිසා ඔයගොල්ලෝ ඕනික් කෙනෙක්ට මේ transition period එක තුළ ඕන දෙයක් කරීමේ freedom එක තියෙනවා. හරි. ඒක නිසා හැබැයි මට last month 2 weeks කරන්න පුළුවන් වුණේ ඒක නිසා මම මේ month එකේ අනිවාර්යෙන් 6 week කරන්න ඕනේ 6 weeks. ඒක නිසා මේ ඔයගොල්ලෝ අපි discussion එකක් යමු. මොකද්ද most appropriate date එක අපිට වැඩි දෙනා මේ participate වෙන්න පුළුවන් විදිහට මේ class එක කරන්න කියලා. හොඳයි. Okay. Then let's go for the lesson. Okay. Today is our first lesson in physics. So I will describe what we will discuss within today. What is our lesson today? Okay. First, today is our first lesson in physics, Puta. So first of all, we are going to introduce about physics. Introduction. So we will do some introduction about physics. What is physics and what is the content of physics? Those kind of things will be discussed. Then there are two types of eras in physics. Classical physics and modern physics. Classical physics and modern physics. We will briefly explain what is the classical physics and what is the modern physics. Then after that we will discuss about classical physics. We will discuss about classical physics and about scientific method. That is our third segment in today's class. Then after that we will go for the lesson. Lesson means unit and dimension. Unit and dimension. That is our first lesson in physics. That is our first lesson in physics. So after doing some introduction, we will go for the lesson. So what is our first lesson? First lesson is unit and dimension. Under this topic, we will discuss about physical systems and physical quantity and about physical quantities and the classification of physical quantity. Then after may define the physical quantities, we will discuss about classifications of physical quantities. After having some knowledge about physical quantity, then we will move to units. Under the physical quantity, there will be some subsegments. After discussing the physical quantity segment, we will move to units. So under that units, we will discuss about the definition of unit. Then what are the available unit system in world? Then we will move to SI unit system. Okay, those are the things we are going to discuss within today's class. Okay, we can go to one by one now. Okay. First of all, we have to get some brief understanding about physics. What is the subject about? I think you have done so many physics theories in your hours. Can anyone tell me some of those? Can anyone tell me what did you learn in your orals regarding physics? What did you learn? Momentum, good. Velocity.
Newton's theories about
Newton theories, very good. Very good. Then kinetic energy, potential energy, then heat energy. Did you learn Q equal mc theta? Q equal mc theta? Did you learn this one? Yeah.
Yes, sir.
Okay. Then what about what else? What else? Okay. I will write some example. Newton's law, no? Newton's law. Then kinetic and potential energy. Kinetic and potential energy. Then heat energy. Then heat energy. Then what else? Waves, no? Waves. Then V equal IR. That is electrical energy. Electrical energy. V equal IR. Then electronics. I think you have done that term also. Electronics. Okay. Can anyone tell me, is there any similarity among these theories? Is there any similarity, Putta? Similarity? Is there any similarity among those theories? Then you can understand what is physics. Can anyone tell me? Yeah, magnetic and electricity. Magnetic field also. Is there any similarity among those theories? Newton's laws, kinetic energy, heat, waves, V equal IR. V equal IR means potential, electric potential. Then, can anyone tell me? Is there any similarity among those theories? Okay. Newton laws. I think you can remember this equation. F equal ma. F equal ma, no? Then kinetic and potential energy. Kinetic energy half mv squared. Potential energy mgh. Then I think you have done Archimedes law and Archimedes principle. No, after C equal to V rho G. Have you done that one? Archimedes principle? No.
Yes.
No. I don't know about all the syllabus. Anyway, then this is V equal IR. V means electric potential. Electric potential also energy. Waves. Waves is waves also energy. It can transmit energy from one place to another place. Heat also energy. So, is there any similarity now? Is there any similarity?
So they're all based on energy then, of course.
Yes, based on energy and matter. Both are there. When we're discussing about Newton's law, there is mass. No, there is a mass. Mass means matter. Mass means matter. So if we consider about kinetic energy, potential energy, all are matter. Then V equal IR. I think you can I will explain this thing in current electricity. This represents also relationship between matter and energy. Waves is a energy transmission method, and energy transmission through a media. Media means matter. So all of those theories about matter and energy and interrelationship between matter and energy. So matter and energy are common in all of those theories. That means physics is about a science. Physics is a science about matter and energy. So normally we are discussing about matter and energy and interrelationship between matter and energy. So that is a basic explanation about physics. Okay. Did you understand that one?
Yes, sir.
Okay, very good. Okay. Shall we write a note? Very good. I forgot to ask that. Actually, I have given you a question regarding Newton's law. I asked you to show all the Newton's law are same. That means Newton's first law and Newton's second law and Newton's third law are same. There are no three laws. There's only one law. We can explain through that through Newton's second law. There are no any three laws. I ask you to try to prove that thing. Have you done that one? Have you done that? No. Okay. If you are unable to prove that thing, you can try that one. Okay. I will explain that thing. Okay. Anyway, I will explain that thing later. If you because there are some new students here, no? So I will give you another week to do that thing. Show all the Newton's laws are same. There's only one law, that is the Newton's second law. Through that, we can prove other two. So there's a challenge. Show that all the Newton's law are same. Okay. You have 1 week. I will explain that thing in the next week. Okay. At the beginning of our sessions, I have told you you have to keep separate books for separate units. So I think today is our first lesson in physics. So it is better to write some notes in a new book. Okay, Buddha? Okay. Shall we write some note regarding introduction? First topic is introduction. Okay. Write down this thing. Physics is a subject. Physics is a subject that explains about matter, energy, and interrelationship between matter and energy.
Sir, can you repeat it again?
Physics is a subject. Physics is a subject that explains matter, energy, interrelationship between matter and energy. Therefore, most of physics theories represent interrelationships between matter and energy. Okay. Okay, Buddha. When we consider physics, physics can be classified into two main categories. We can classify physics into two main categories. Those are classical physics and modern physics. Classical physics, normally it is called as Newtonian physics. Normally it is called a Newtonian physics. Okay. What is classical physics? Actually, classical physics was developed by Sir Isaac Newton. Isaac Newton is the father of classical physics. Most of, I think, actually, more than 80% of theories were introduced by Sir Isaac Newton. So that's why we call it as Newtonian physics. Normally, this classical physics describes about macro world. This describes about macro world. Macro world means that's about this our normal world. We can sense, using our five sense, that is macro world. That is macro world. So actually, Newton describes about our day-to-day life, applications of physics about our day-to-day life. Okay, so classical physics is based on macro world, because classical physics explains the phenomenon in macro world. Okay, I think you have learned Newton's law in all of us. We can apply Newton's law for motion. That means if there's any motion in an object, we can apply Newton's law. Okay, if there is any motion in object, means we can observe that thing. We can observe that thing because it is in macro world. Okay, so we can apply Newton's law to the macro world applications. Okay, so Newton's law valid, Newtonian physics and classical physics valid for macro world applications. But after some time, scientists have do some experiment, no, not experiment, actually do some observation. They had some observations regarding micro world application, especially in atomic level applications. In atomic level application, that's mean micro level application, they couldn't apply Newton's law to explain those applications. Okay, especially I think you know about I think you have done in chemistry in all levels regarding atomic structure. There is a orbital around nuclei, and electrons can be moved along this orbital. Actually, it can be considered as a circular motion. Okay, it can be considered as a circular motion. We can apply some Newton's theory regarding circular motion to explain the motion of electrons. But unfortunately, Newton's law cannot be used to explain fully nature of electrons. That means Newtonian physics cannot be used to explain micro level application. Therefore, after some times, a new era of physics has been formed that is called modern physics. Especially Max Planck, Albert Einstein, Niels Bohr, those are the prominent characters in modern physics. I think you have heard about quantum physics. Quantum physics, actually, that is a branch of modern physics. So, but the thing is still the Newtonian physics is valid for macro world application. Therefore, in our A levels, we will learn up to unit number 10. Up to unit number 10 about classical physics. Unit number 11 is the only unit we can learn about modern physics. Okay, so normally in G.C.E. level, we will learn classical physics. That means macro level applications. Okay, I think if you have any doubt, please let me know. Okay. Okay, you can write that one. In a new paragraph. In a new paragraph. Okay. physics can be classified into two main categories. First one is classical physics. Second one is classical physics. Within the brackets, you can write Newtonian physics. Classical physics. Within the brackets, you can write Newtonian physics. Second one is modern physics. Most of theories in classical physics were introduced by Sir Isaac Newton. Classical physics is based on macro level applications. In a new paragraph, classical physics theories cannot be used to explain micro level applications. Therefore, A new branch of physics. A new branch of physics. A new branch of physics. Has been introduced. Has been introduced. To explain those phenomena. To explain those phenomena. To explain those phenomena. That is called as modern physics. That is called as modern physics. Modern physics. Okay. Okay, up to now, we have discussed about physics. So, in the section, we have explained physics is a subject that describes about matter and energy. Then, we classified physics into two categories that are classical physics and modern physics. And we are going to study about classical physics further. We will study about modern physics too, but that is in unit number 11. Up to that unit, we will study about classical physics. So now we are going to study about classical physics. Classical physics. Okay. So now we are going to study about classical physics. So we have to know how to derive an expression or theory in classical physics. We have to know about that. That's mean, let's assume if we equal mv or q equal mc theta expression, so equations. Those are equations you have done in follows. Okay. So suppose we have to get some expression or get some equation regarding heat energy. That means we have to develop an expression or an equation to express heat energy. What are the factors affecting to heat energy and how they are combined with heat energy? Those are the things we have to investigate. Suppose we have to investigate. So there is a method of investigation in classical physics. There is a method that is called as scientific method. Scientific method. Scientific method is the method of investigation in classical physics. Okay. In scientific method, actually this is a theoretical part, Puta. This may be boring, but we have to teach that thing. So please clearly understand this thing, okay? Okay. This is a very theoretical part. Okay. Okay. In classical physics, there is a method to investigate about macro world phenomena. That is called as scientific method. Scientific method, first of all, we have to have some observation. That means, suppose we are very close to a fire. There is a fire and we are very close to fire. Then you can feel the heat transferred from that fire. No, you can feel that. That is our observation. What is our observation? When we near to a fire, we can feel the heat. We can feel the heat. We made observation. Now we are going to investigate what is the reason for that observation. That means fire is something here. I am standing something here. We do not have any connection. We do not have any connection unless they are. But still I feel the heat. Still I feel the heat. That is the observation. So in scientific method, the first thing is the observation. Once we observe some phenomena, we are going to investigate what are the reasons for this phenomena and what are the factors affecting to that reason. Okay. Therefore, the first thing in classical physics, is observations. Observation. We observe some natural phenomena. We observe some natural thing. Then we are going to investigate what are the reasons for this phenomena. Okay. As an example, we are sitting very near to a fire. Then we can feel the heat. That is my observation, Putta. That is my observation. Then I am going to investigate what are the reasons for this observation. So first thing, under the scientific method, first thing is observation. Observations. Observation means observations regarding natural phenomena. Okay. Once we did an observation, then the second step is we are going to do some assumptions or hypothesis. That means I will assume the reason might be this one. Reason for heat transferring might be this one. I'm going to assume that thing. So my second step is hypothesis. Hypothesis or assumption. Assumption. First one is the observation. Then I will assume the reason for that observation. That is my second step. The third step is I want to check whether my assumptions are correct or not. For that, I am going to do some experiment. I'm going to do some experiment. So my third step is doing some experiment. Doing some experiment to check whether my assumptions are correct or not. That is my third step. Okay. After conducting the experiment, I can decide, I can conclude whether my assumptions are correct or not. if there is anything to change, I can change according to the observation through the experiments. So according to the observations in experiment, I can accept my assumption or change where it is necessary. Okay, that is my third step. So my fourth step is, if those assumptions are correct, or if I made some changes through this experiment, then I can build a theory. I can build a theory. I can build a theory. So after the assumption, we can clearly conclude the actual factors that affects to this observation. So according to this experiment, I can make a theory. Okay, so the fourth step is performing or creating a theory, new theory. Okay, so you can, if you may have some observation, and you can use this scientific method, and you can build your own theory and get your name. Assign your name to that theory. Newton did the same thing, no? Newton do some experiment and may form a theory, and he assigned his name to that theory. Then the fifth one. After building a theory, we cannot do nothing. Okay, we have to do some experiment again and again. We have to do some experiment again and again according to the new experience. According to new experience or new theories, we have to do the experiment again and again, and we have to check the validity of theory. We have to check the validity of theory, because some experience can be cause some changes in theory. Therefore, according to the experiment, according to new experiment, and according to the new experiments, we can make some changes to our theory. So we have to check the validity of the theory continuously. We have to check that according to our new experiences. So those are the basic steps of investigation in classical physics. This is called as scientific method. Do you get my point? තේරුණාද? තව explain කරන්න ඕනිද? තේරුණා නම් yes කියන්න. නැත්තම් කියන්න.
Yes, sir. There.
Okay. Good. මේක ඇත්තටම මේ තියරි පාර්ට් එකක් මොකද මේක තියරි පාර්ට් එකක් මේවා ඇත්තටම ඉවලුවේට් එකම අඩුයි නමුත් මේවා උගන්වලා තියෙන්න ඕනි මොකද සිලබස් එකේ තියෙනවනේ ඒකයි මේ හොඳේ හරි okay let's write a topic scientific method scientific method scientific method scientific method under this topic, write this paragraph. There is an investigation criteria. There is an investigation criteria. Investigation criteria in classical physics. In classical physics. Theories in classical physics. Theories in classical physics. Theories in classical physics are formed according to that method. It is called as scientific method. It is called as scientific method. The following steps should be followed in this method. Number one, observations. Observations of natural phenomena, observations about natural phenomena, sorry, can be done as the first step of this method. Observations about natural phenomena can be done as the first step of this method. This is a data collecting step. This is a data collecting step. Of an incident. Second step. Hypothesis or assumptions. Hypothesis or assumptions. Then the reasons for the observations, then the reasons for the above observations I assume. So we can make a hypothetical theory. So we can make a hypothetical theory regarding the observations. they had done experiments. Experiments can be performed. Experiments can be performed to conclude whether the assumptions are correct or not. Whether the assumptions are correct or not. Fourth one, theory. Once we have a conclusion, through the experiments, we can build a theory. Once we have conclusion, once we have conclusions, through the experiments, I'm repeating this one only. Once we have observations, so once we have conclusions through the experiments, we can build a theory. We can build a theory regarding the observations. Last one. Prediction or validation. Prediction or validation. Prediction or validation. If we have new experiences, we can repeat the process. If we have new experiences, we can repeat the process. To check the validation of the theory. To check the validation of the theory. If there are changes to be done, if there are changes to be done, if there are changes to be done, we can revise the theory. We can revise the previous theory. We can revise the previous theory. Okay. Do you have any question regarding scientific method, Puta? Do you have any question? What did you understand? Do you have any question regarding this scientific method? Hmm? Or did you get my point? If so, please give the comment. Your comment.
Yes, understood, sir.
Okay, very good. Thank you. Okay. Actually, this is a theory part, Puta. This is a theory part. Most of the cases, those can be asked in your term test papers, not in A-level paper. Okay. Okay. Anyway, this is in our syllabus, so we have to teach and you have to learn. Okay. This is about scientific method. Okay. Now we are done with introduction. Now we can move to our lesson. Unit and dimension. Unit and dimension. Units and dimensions. Actually, in physics, we had actually we have discussed about experiment, doing some experiment in scientific method. No, so when we are doing experiment, we have to take measurements. Actually, physics is about measurements. We have to take a lot of measurements. Okay. When you are calculating F equal ma, no, when you are calculating F equal ma, suppose you have mass and acceleration. If you have mass and acceleration, that means you have measured that thing. You have measured the mass of the object. You have measured the acceleration of that object. You have measured that thing. No, after that you will calculate F. So anyway, you have to measure some properties in physics. So physics is about measurements. That's why this is our first unit. We have to understand how to take measurements, what are the measurements we are going to take. So those kind of things we have to understand before we study physics. So actually this is not about physics. The first lesson is not about physics, but this is about measurements. How to take measurements. What are the measurements? Those are the things including this topic. Okay. Actually, the first lesson is not about physics, it's about taking measurements. Taking measurements. Okay, because physics is about measurements. I think you have done in all levels, you have calculated so many things. No, you have calculated so many things in physics questions. No, F equal ma, h rho g, half me squared in mgh, that kind of thing. You have calculated. You have calculated means you took some measurements. No? So measurements is a core part in physics. Anyway, now we have discussed about measurements as the first topic of physics. So first of all, we have to get some understanding about physical system. Physical system, Buddha. Physical system. Listen very carefully. Do you have any idea about physical system? Physical system. Can anyone tell me what is a physical system? I don't know whether you have done in all else or not, but can anyone tell me what is a physical system, Puta? What is a physical system? Listen very carefully. What is a physical system? මොකද්ද physical system එකක් කියන්නේ? What is a physical system? Suppose there's a system. There's a system. There's a system. If any system has a measurable property, if any system has a measurable property, that system is called as a physical system. If any system has a measurable property, that system is called as a physical system. Okay. Suppose there is a rectangular box. Suppose there is a rectangular box. Okay, tell me, is this a physical system or not? Is this a physical system or not? The rectangular box.
Yeah.
Yes.
Yeah.
Why are you saying this is a physical system? What is the reason?
Because the box can be measured.
Yes, this box can be measured. The length of box, sorry, height of box can be measured. The width, length also can be measured. The weight, that also can be measured. What else? What else? Area, the surface area can be measured. What else? Density also can be measured. Those are the properties. Those are the properties that can be measured in the system. So this system has measurable property. So this can be considered as a physical system. With a physical system. Do you understand what is physical system? Okay. Write a topic. Our main topic is units and dimension. Under that topic, a subtopic, physical system. Physical system. Physical system. Under that topic, if any system has a measurable property, if any system has a measurable property, measurable property, that system will be called as a physical system. That system will be called as a physical system. You can draw this image as example. height, length, width, density, mass, surface area. Those properties can be measured. Once you draw the image, please may give me a thumb. Then I can understand you have done. Very good. Okay. Right under this image, suppose there is a rectangular box. There is a rectangular box. It is very clear. It is very clear. It is very clear. That we can measure. That we can measure. That we can measure. The above mentioned, that we can measure the above mentioned properties of the box. Of the box. Therefore, we can consider this as a physical system. We can consider this as a physical system. Okay. Okay. I think you can understand about physical system. So a physical system have some properties that can be measured. Okay. Consider those properties: height, length, width, mass, surface area, density. Consider those properties. So you can clearly see height, length, width, mass. Those kind of properties, Puta, we can measure directly. We can measure directly, no? We can use ruler to measure height. We can use same ruler to measure length and width. And we can use a balance to measure mass. No? Those kind of properties we can measure directly. But if we consider about surface area, density, those kind of physical properties, we cannot measure them directly. If you want to measure surface area, you have to take the height and width and you have to multiply both properties. Then you can get surface area. If you want to get density, we can measure the density, but we cannot measure the density directly. We have to take the mass. We have to take the mass and we have to determine the volume. Then mass divided by volume means density. So those kind of properties can be measured but cannot be measured directly. So if we consider physical properties, some properties can be measured directly. Some properties can be measured directly. Some properties can be measured directly, while some properties cannot be measured directly. That means we can measure them indirectly. We can measure them using those directly measured properties. Okay. Do you understand this? Do you get my point? So there are two kinds of physical properties. What are them? Some properties can be measured directly, while other properties cannot be measured directly. That can be measured using directly measured properties. Okay. Okay. So if there is a property of a physical system that can be measured either in directly or indirect method, that property is called as a physical quantity. What is that? Physical quantity. Very important name. Physical quantity. So according to the definition of physical quantity is a property of a physical system that can be measured directly or indirectly. So according to definition, all of them are physical quantities. All of them are physical quantities. What are the physical quantities, Muta? Physical quantities are the properties that can be measured directly or indirectly. Do you understand? Do you get my point?
Yes, sir.
Very good. Okay, right. Another topic: physical quantity. Physical quantity, very important topic. Physical quantity. physical quantities are quantities are the properties of a physical system. Are the properties of a physical system that can be measured directly or indirectly. I will explain, Buddha. That can be measured directly or indirectly. Physical quantities are the properties of a physical system that can be measured directly or indirectly. Let's assume, okay, finish this one. Okay, I will explain again. Okay. Suppose the same system which you used in this previous case, this one, this rectangular box. Okay. Huta, you can take a ruler and get height, length, width. Those can be measured directly, without calculating something. You can measure them directly. You can use meter ruler. You can use meter ruler to take the measurement of those things. You can measure the mass directly. You can use a balance. You can use a balance and get the value of mass. But can you measure the surface area? Can you measure the surface area using a measurement instrument? Can you measure? You cannot measure, no? You cannot measure. If you want to measure the surface area, you have to measure the height and the width. Then you have to multiply those two quantities. No? That's why we call the surface area is an indirectly measured physical quantity. Indirectly measured one. This is an indirectly measured one because we cannot measure the physical quantity using a measuring equipment. We cannot measure. If you want to calculate this one, we have to measure the height and the width, then we have to multiply both. Then something like density. If you want to find density, there is no any measuring equipment, no? You have to find the mass first, then the volume. Once you calculate the volume and take the mass, then you can find the density. That's why we are calling this as a indirectly measuring property. Okay. Now, do you understand that thing? Very good. Very good. Very good. That's why we call direct method than indirect method. Okay. Okay. We have defined physical quantity. So, under that paragraph, we will write some example. Okay. We will write some example. So, write it as example. Example number one. Example number one, Puta. Example number one. Consider the above rectangular box. Consider the above rectangular box. We can use a meter ruler. We can use a meter ruler we can use a meter ruler we can use a meter ruler and take height, length and width. Height, length and width. We can use a balance. We can use a balance. We can use a balance and measure the mass. Measure the mass directly. So those properties can be measured directly. Can be measured directly. Second example, second one. If we consider surface area, we consider surface area, we cannot measure it directly. We cannot measure it directly. we have to measure the height and the width. We have to measure the height and the width. To calculate the surface area. To calculate the surface area. In a new paragraph, likewise, the density of the box, cannot be measured directly. In a new paragraph, therefore, all the above properties can be measured by a direct method, or the indirect method, or an indirect method can be measured by a direct method or an indirect method. Therefore, all of them, All of them are physical quantities. All of them are physical quantities. Okay. If we consider about physical quantities, that can be divided into two major categories. What are those? Directly measurable properties and indirectly measurable properties, because those are the two main categories of physical quantities. Physical quantities are the properties that can be measurable, no? That can be measured. If any property can be measured, that should be a physical quantity. But that measurement either can be measured either in a direct way or an indirect way. Okay. According to the way of measurement, there are two kind of physical quantities. One can be measured directly, other one can be measured indirectly. Okay. What are the physical properties? What are the properties that can be measured directly, Puta? Now you have two examples. What are those? Length and mass. Length and mass can be measured directly. Now you have two examples. Likewise, can you give me some more examples? What are the properties that can be measured directly? What are the properties? Give me some answers. You can consider any physical system now, okay? I have considered only the rectangular box now. Now you can consider any physical quantity, physical system. What are the properties that can be measured directly? Length,
Temperature.
mass.
Temperature.
Sorry?
Temperature.
Time. Yes, that is a good answer. Time. Another one? Time. You said temperature, no?
Yeah, sir. Temperature.
I hate acceleration. Temperature is correct. Temperature is correct. Okay. Time, temperature. Very good answer. Angles. Very questionable answer. Okay. Angles. Okay. Time. Yeah. We did two things previously. What are those? Length. Length. Second one, mass. Now you have given time. That is also correct. Other one, temperature. That is also correct. Very good answer. is there. Angles. Very questionable answer. I will explain that thing. Although angles can be measured directly, we are not categorize it as direct method. Okay, I will explain that thing later. Okay. Angles that can be measured directly. Actually, I have asked me the properties that can be measured directly. No, so this can be measured directly. Okay. Okay. I think those are the things you know. So in addition to these four, there are three other properties. What are those? Electric current. It can be measured directly. Then amount of substance. Amount of substance. Amount of substance, I think you have done in your always about moles. Have you done moles? About moles? Chemistry. Amount of substance is measured by moles. It can be measured directly. You will learn that one in chemistry, okay? Amount of substance. The seventh, the final one is luminous intensity. Luminous intensity. Those seven properties are the only properties that can be measured directly, Putha. That can be measured directly. Angles can be measured directly, but we are not. Those are not categorized under this category. I will explain that till lately. So, beside this one, those are the only seven properties that can be measured directly. So, there are only seven properties that can be measured directly. Therefore, these properties, that means those physical quantities, those are physical quantities. No? Those physical quantities are called as fundamental physical quantity. What is the name? Fundamental physical quantities. Fundamental physical quantities or basic physical quantities. So, what are the fundamental physical quantity or basic physical quantity? Physical quantities that can be measured directly, Putha. There are only seven physical quantities that can be measured directly. What are those? Length, mass, time, temperature, electric current, amount of substance, and luminous intensity. Those are the only seven properties that can be measured directly. Okay. Then, other side. What are the properties that can be measured indirectly? There are so many properties. Can anyone tell me? Give me examples. What are the indirectly measurable properties? Though there are a lot of things.
Force.
Force, very good.
Acceleration. Velocity.
Very good.
Volume.
Volume. What else?
Density.
Power, right?
Speed.
Speed, yeah. Power is speed. Power is speed. Weight also correct. Weight is a force. Weight is a force. Pressure also
Pressure.
correct.
Pressure.
Pressure also correct. Pressure also correct. Energy also correct. Pressure, energy. Yeah, you are good. So there are a lot of properties that can be measured indirectly. So those are the two kind of physical quantities. Okay. Up to now. Okay. Up to now, we have done about physical system. We have discussed what is a physical system. Then we have discussed about physical quantities. When we were discussing about physical quantity, we have discussed there are two kinds of physical quantities as per the measurements, as per the measuring way, as per the way of measurement. What are those two physical quantities? Directly measurable physical quantity and indirectly measurable physical quantity. Okay. So we have learned about physical system and physical quantities. Now we are going to classify the physical quantity. We can classify the physical quantity. Actually, now we have done the classification, no? This classification is based on the way of measurement, the way of taking measurement. Okay. If we can take the measurements directly, those are classified under directly measurable properties. If the properties are measured indirect way, then those properties can be classified under indirectly measurable properties. Okay. But no, they are given, maybe those properties are given very specific names, very specific names. Directly measurable properties are called as fundamental physical quantities or basic physical quantities. Those are the physical quantity that can be measured directly. So they are called as fundamental physical quantities, fundamental or basic physical quantities. Okay. Look at those physical quantities. You can calculate those physical quantities using the fundamental physical quantity, no? Let's assume you have to calculate velocity. If you want to calculate velocity, then you have to measure the displacement. That means length. And you have to divide it by time. That also fundamental physical quantity. No? So if you want to find this kind of physical quantity, you have to use fundamental physical quantities. Suppose the volume. If you want to find volume, you have to measure 3 lengths. You have to measure 3 lengths. No? That means you have to take fundamental physical quantity. No? So those are called as derived physical quantity. Derived. That means those are derived using fundamental physical quantity. Do you understand? Those are derived using fundamental physical quantities. That's why those are called as derived physical quantity. Suppose the velocity and the volume. How to derive velocity? How to derive velocity? You have to divide the displacement over time. Displacement is a fundamental physical quantity, time is a fundamental physical quantity too. So you have used two fundamental physical quantities to derive this one. Therefore, these physical quantities are called as derived physical quantities. And those are called as fundamental physical quantities. Do you get my point? If you need any further clarification, I can give you. Do you understand? Very good. Very good. Okay. Now we are going to classify physical quantities. Our first method is classification using the way of taking measurement. The way of taking measurement can be divided into two categories: direct measurements and indirect measurements. If we consider direct measurements, there are 7 physical quantities that can be measured directly. Those are called as fundamental physical quantities. And if we consider the indirect way, there are a lot of physical quantities, but all of them are derived using those fundamental physical quantities. Therefore, these are called as derived physical quantities. Okay. Write a topic: classification of physical quantities. Classification of physical quantities. Classification of physical quantities. Physical quantities, right under this topic, physical quantities can be classified according to two criterion. First method. First method. First method is according to the way of taking measurements. physical quantities that can be measured into two categories. First one is fundamental. Fundamental physical quantities. Fundamental physical quantities. Second one is derived physical quantities. Fundamental physical quantities are the physical quantities directly measurable. Directly measurable. Those are the physical quantities that can be indirectly measurable. Indirectly measurable. There are 7 fundamental physical quantities. What are those? Length, mass, time, temperature, electric current, amount of substances, substances. 7, luminous intensity. Luminous intensity. Those are the fundamental physical quantities. Derived physical quantities. There are a lot of things. Velocity, volume, density, power, energy, Once you finish writing, please let me know using a thumb. Okay. Okay. You can write under this classification. Can you hear me? Okay. You can write under the classification. According to the way of taking measurements. According to the way of taking measurements. Physical quantities can be classified into two main categories. The properties that can be measured directly. The properties that can be measured directly are called as fundamental physical quantities. Fundamental physical quantities are called as fundamental physical quantities. There are seven number of fundamental physical quantities. There are seven number of fundamental physical quantities. Under new paragraph, write down the physical quantities, the physical quantities such as velocity, comma volume, comma density, etc. are derived using fundamental physical quantities. Therefore, those are called as derived physical quantities. Derived physical quantities. Those are called as derived physical quantity. Actually, okay, right then. Okay, listen to me. When I ask about directly measured physical quantity, there was a good answer. That was angle. 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 What about this? Angles. Can they measure directly? Can they measure? Angles. Can they measure directly, Puta? Angles can be measured directly, no? Angles can be measured directly, yeah. Angles can be measured directly. No? These can be directly measured. Although the angles can be measured directly, there is a limitation. There is a problem. What is that? That is the definition of the angle, definition of the radian. I think I have discussed about this thing in last Wednesday, the radian. According to the definition of radian, we have derived this equation, S equal R theta. S equal R theta equation, I will explain this thing. S means Puta, arc length, R means radius, theta means the angle measured in radius. Something like this. I will explain this thing again. What is an arc? Arc is a portion of the circle, So this is the arc length. This is the length of arc. That is called as S. That is called as S. If we measure the angle in between these two radius, and suppose the length of radius is R, the relationship between those three parameters is something like this. S equal R theta. Theta should be measured in radian. That is the definition. This is derived using the definition of radian. Okay. According to this definition, if we subject theta, what would be happen? If we subject theta, it will be equal to S over means S means it is a length. R also a length. S also a length. R also a length. Length divided by length. Length divided by length. That means If you, for easy understanding, let's put up meter. Normally, length is measured by meter, no? So this is measured by meter, and this is also measured by meter. So if we divide those two, meter to meter will be cancelled out. Meter to meter will be cancelled out, and theta is just a number. It is theta is equal to ratio of two length. Ratio of two length. So this should not have any unit. Theta should not have any unit because meter to meter should be cancelled out. Meter to meter should be cancelled out. So this should not, the theta should not have any unit. But we have to assign a unit for measurement angle, for measuring angle. Otherwise, we cannot deal with angular things. We have to assign a unit. Okay. But according to the definition, there should not be a unit. There should not be a unit because length divided by length, meter to meter will be cancelled out. So this is just a number. This is just a number, Putta. I don't know. Do you understand what I'm saying? This is just a number. Do you understand what I'm saying?
Yes, sir.
Very good. This is just a number, Putta. So according to definition, this should be a number, but we have assigned a unit for theta, for angle. That is radian or degree. Okay. So there is a contradiction. There's a contradiction. Therefore, they do not categorize theta as a fundamental physical quantity. That's why, although the angle can be measured directly, those are not categorized under fundamental physical quantities. Okay. But those are not derived physical quantity. Those are not derived physical quantity because that can be measured directly. Therefore, there is another category. There is another category which is called as supplementary physical quantities. There's another category which is called supplementary physical quantities. Under this category, there are two physical quantities. What are those? First one is plane angle. Second one is solid angle, both angles. Plane angle is the angle where you have dealing your orals, because plane angle is the angle measured on a plane. It is on a plane. What is a solid angle? What is a solid angle? Let's assume a 3D model, 3D cube or something. If we assume this kind of 3D model, Putta, there is a angle, three-dimensional angle, no? You can see there is a three-dimensional angle. This kind of angle is called as solid angles. Those are not in a plane. Those are not in a plane. Those are three-dimensional angles. That's why these are called as solid angles. Let's assume some cone. If we take this angle inside, it is also a 3D angle. It is also a 3D angle. If it is a 3D angle, it is categorized under solid angles. Okay. So there are two types of angles, plane angle and solid angle. Plane angle are the angles which are in a plane. Solid angles are the angles. Solid angles are the 3D angles, three-dimensional angles. Okay. So under the supplementary physical quantities, there are two physical quantities, both are angles. Both are angles. One is plane angle, other one is solid angle. Okay. Therefore, the scientists categorize angles separately. So angles are categorized separately, not under some fundamental physical quantity, or not under the derived physical quantity. Those are categorized under a separate physical quantity. Okay. Those are called as supplementary physical quantity. Do you understand? Do you understand? There another? Okay. Write down this one. Write down this one. In a new paragraph. If we consider angles, if we consider angles, that can be measured directly. But they are not categorized under fundamental physical quantity. They are not categorized under fundamental physical quantities. As per S equal R theta equation, as per S equal R theta equation, theta is equal S over R. Theta is equal S over R. That means theta equal to a length divided by a length. Length divided by a length. That means theta equal to length divided by a length. Length divided by a length. So it should not have a unit. It should not have a unit. But we have to assign a unit for angles. Therefore, this is a special case. So angles are categorized under a new category. So angles are categorized under a new category which is called as supplementary physical quantities. Supplementary physical quantities. Yes, that is correct. That is correct. It is seen to be a derived physical quantity, but it can be measured directly. That is a contradiction. And other thing is, it should not have a unit, but it has a unit. Those are the contradiction with angles. Therefore, angles are not categorized under the above two category. That's why it is categorized under a new category. Putta, you are correct. You are very correct. According to the derivation, theta is equal to S over R. S over R means it is seemed to be a derived physical quantity. Okay, but it can be measured directly. That is a problem. It can be measured directly. That is the contradiction between the definition and the actual thing. Okay, that's why it is called, it is categorized under a new category. Okay. No. Fundamental physical quantity have units, but there is a contradiction. There is a contradiction because theta is equal S over R. Theta is equal S over R. S over R means length over length. Length over length means theta should not have a unit. It should not have a unit, but we have to assign a unit for theta. That is a problem because we have to measure the rotation. No? If we want to measure the amount of rotation, we have to assign a unit for theta. But according to this definition, it should not have a unit. That is a contradiction. That's the problem. There's a contradiction. According to this derivation, according to this definition, theta should not have a unit. But if theta does not have a unit, how can we measure rotation? That's the problem. If we want to measure rotation, we have to assign a unit for theta. That's why we assign radian and degree for theta. Okay. From that, we can measure the amount of rotation. That's why we assign a unit for theta. So we have to assign a unit for theta, but according to this definition, theta does not have a unit. So there is a contradiction. There is a contradiction. Due to that contradiction, they treat angle as a special physical property, physical quantity. Okay, that is the thing. Istio, can you explain your question, Putta? Istio, I cannot get your question. Can you explain that one?
So then what about the quantities, that means the measurements we take as degree and radian for angles?
Sorry? That means you are asking about degree and radius. If it is
Yes, sir, we measure them with degrees.
No, normally Putta, normally radian is the SI unit of angles. We will learn in future lessons. The radian is the SI unit of angles. So we have to use radian. We have to use radian instead of degree. Therefore, if we want to use radian, this kind of problem will be happen. Okay. Therefore, there is a contradiction in measuring angle. That's why they treat angles as a special case. Okay. That's why that's why the angles are categorized under special category. Okay. Write down this topic. Supplementary physical quantity. Supplementary physical quantity. There are two supplementary physical quantity: plane angle and solid angle. You can draw the plane angle and solid angle. Once you finish this one, may I please give me a thumb. Okay, have you done this one? Good. Okay, Buddha. Okay. Shall we discuss? Okay. Our today's lesson, we have discussed about an introduction of physics. According to that introduction, we have learned that physics is a subject that describes about matter and energy and interrelationship between matter and energy. Then we move to two categories of physics. Those are the classical physics and modern physics. Then we discuss about the classical physics, the way of interpretation, the way of building a theory in classical physics. We have discussed that thing. It is called as scientific method. After that brief introduction, then we move to physics, the first unit of physics, that is unit and dimension. Under that topic, we have discussed what is a physical system. What is a physical system? Then what is a physical quantity? What is a physical quantity? Then the classification of physical quantity. What is a fundamental physical quantity and derived physical quantity? And there is another subcategory, that is supplementary physical quantity. Under this subcategory, angles are categorized under this subcategory. Okay, those are the things we have discussed within this class. Do you have any question up to this session, up to this point? Do you have any question for that? Because you should leave the class without having a problem. So I have to clear all the things. If you have any problem, please let me know. If you have any question, please ask this thing. Please ask, okay? Do you understand the theory? Okay, very good. Others? Very good. Very good. Good. This is a basic thing about physics. Then in the next class, we can discuss about units. Then we can go to the dimensions. After completion of the dimension, we have to do a lot of calculations thing. Okay. So if you have any question, you should clear it before go to the further advanced parts. Okay. Anyway, now it's 12. We have to finish the session. If you have any question, now it's time for you to ask any question from me. Charge. Charge is a derived physical quantity, too. It is a derived one. It is not, charge cannot be measured directly. Charge is a derived physical quantity. I'll explain it in unit number 5, unit number 6, electric field. Charge is a derived physical quantity. Okay, very good. So then We can finish the session. So good afternoon all. අයිබෝන් පුතාලා. එහෙනම් ඊළඟ සතිය හම්බෙමු. Okay?
Good afternoon, sir.
Good afternoon.